Today we're going to teach you how to take antiderivatives. To do this, we must use the reverse power rule. So for this example, the first thing we would do is raise the exponential factors. This would become x squared, instead of just x, plus 3x plus c. Next, we're going to multiply each term by the reciprocal of the new exponent. So we would have to multiply x squared by 1/2 and 3x squared, or 3x by 1 plus c. So now the answer is x squared over 2 plus 3x plus c. And we have another example for you as well. This one is a little bit more complicated, but you do the same thing. It's 3x squared plus 4x minus 7 dx. For this one, you would change it to 3x to the third and multiply it by 1/3 because that's the reciprocal of the exponent, and add 4x now squared and multiply it by 1/2 because that's the reciprocal of 2. Then make it minus 7x, and you need to add c, which is your constant. Now this would become x to the third plus 2x squared minus 7x plus c. And you can always check this antiderivative by taking the derivative, and you would end up getting 3x squared plus 4x minus 7. So that is how you take the antiderivative using the reverse power rule. And next we will teach you how to use u-substitution to take antiderivatives.
Hi, today we're going to be learning how to do u-substitution also. This is because some of the problems are too complicated to totally factor out. So when you have a composite function, you must use u-substitution. So here is our first example. You could do this if you did not know how to do that. You could multiply it 5 times, but it would be a lot easier if you knew how to do u-substitution. First you need to find the u, which is the inner function. So u equals 2x plus 1. And then you take the derivative of that to find du. du equals 2 dx, because we're not going to x. Then you're going to solve for dx. So dx equals du over 2. And then you're going to plug it into the equation. So then here's your equation over here. It's going to be u to the 5th, like here, but you're just going to replace this with a u. And then du over 2, which replaces your dx. So after here, you can take out the 1/2. So take out your 1/2, and then you just have u to the 5th du. And then you're ready to plug in your antiderivative, or you're taking the antiderivative. So 1/2 still. You raise yours to a power, and then you times it by the reciprocal, so 1/6. And then this turns into plus c. And then you're going to plug back in your u. So 1/2, 1/6, and then you're going to plug in your u, which is 2x plus 1 to the 6th plus c. And then you just simplify it. So you can take out the 1/6, so it would be 1/12, and then 2x plus 1 to the 6th plus c. And that's how you take it with u-substitution. There's a few more examples, just so you're clear with it. next example is a little bit more complicated, using a square root. So we're going to take the derivative of x minus 5 times the square root of x plus 1 dx. Okay, so in order to do this, you rewrite it, so it's x minus 5 times x plus 1 to the 1/2 to get rid of your square root, dx still. And then you're going to find your u. Since this is raised to a power, that is your u. So u equals x plus 1. Then take your derivative, so du equals 1, du equals dx. So it's going to be 1 and then dx because you're solving for x. And then you're going to solve it because this, you're trying to get rid of the x minus 5. You need to solve it in terms of x minus 5. So to get u equals x plus 1, you're going to change it so it's u minus 6 equals x minus 5. And so you can plug it in terms of u. Then you're going to go ahead and plug it into your equation. So we're going to bring it over here. So it's going to be plug in for x minus 5, that's equal to u minus 6. And then you just do u to the 1/2 plus dx. There you go. And then you're going to take your antiderivative. So it's going to be, first you have to distribute this so that you can have one whole sentence. 1 to the 3/2 minus 6 u to the 1/2 dx. Okay, now you take your antiderivative. So you raise it to a power, so u to the 5/2 times it by the reciprocal, which is 2/5, minus u to the 3/2, 6u to the 3/2, times the reciprocal, which is 2/3. And then this turns into plus c. And then you're going to just simplify the problem. So it's going to be 2/5 u to the 5/2 minus 4u to the 3/2 plus c. And then you plug in your u. So your u was x minus 5, or
X
your u
plus
is
1.
x plus 1. So it's going to be 2/5 x plus 1 to the 5/2 minus 4 x plus 1 to the 3/2 plus c. And then that is how you find your antiderivative with u-substitution. Thank you.